In this video, we're going to consider the translation of functions, moving them left, right, up, and down. I'm going to focus on moving left and right. The reason why is because if y equals f of x, we know the graph of that is a parabola. The vertex of 0, 0 at the origin. If I add a number to this, let's say 3, we're just adding 3 to every y value, and because this is our y value, the vertical axis, adding a number, it's going to move it up, in this case by 3. Same for subtracting, it moves it down. But what about left and right? Alright, so we know the rule is, let's consider g, and let's say g is x minus 3 quantity squared. So in other words, g we could think of as f as a function of x minus 3, because this notation means we go back to f, and wherever there's an x, we plug in x minus 3. So when I plug in x minus 3 there, we get x minus 3 quantity squared. Now we know that if we have f of x minus 3 shifts the graph of f to the right 3 places. But why? So the graph of f of x equals x minus 3 is going to be the graph of our parabola. It's going to take this and it's going to shift it to the right 3 places. But why does it do that? Well, let's consider this. F of 0 is 0 squared, which is 0. Now let's consider g. How do we get 0? Well, when I plug in 3 into g, we get 3 minus 3 is 0. So g of 3 is 0 squared, which is 0. Now notice the difference between these two numbers. 3 is to the right of 0 by 3. Well, now let's consider f of 1. Well, it's just 1 squared, which is 1. For g to get 1, we need 4 minus 3. So g of 4 gives us 1 squared. And again, we notice 4 is to the right of 1 by 3. And let me just do one other example. Let's say f of 2. Well, that's 2 squared. Well, how do we get 2 squared for g? For g, in order to get 2, we need a 5, because 5 minus 3 is 2. And again, we notice the difference between these two x values is 5 is to the right of 2 by 3. That's our difference in x values, and it moves the graph to the right by 3 places. And that illustrates why.